So this problem can be done in a couple of ways, but this is really where the division statement can be very handy. Okay, so we have our polynomial of x. Okay, it's divided by x minus 2 and x plus 1, and we get a remainder that is 3x minus 2. And so what it's asking is, what's the remainder when we only divide by one of these factors? Okay, well, if I look at the division statement looks like this. The polynomial is equal to, okay, so it's going to be q of x times the d of x plus the remainder of x. Okay, so this is what my remainder statement looks like. My division statement looks like. So we have no idea what p of x is. We really have no idea what q of x is. We do know that the d of x is going to be these two divisors here. Okay, so these two divisors represent my d of x. And we know that the r of x is going to be this piece here. Okay, so what we want to do is we want to divide this polynomial by x plus 1, and we want to figure out what the remainder is. Now, this is kind of complicated to think about. However, let's write out what we do know. Let's put in what we do know. So we have p of x unknown, q of x, which is unknown. Our d of x is known though. We know we have the d of x is represented by these two factors. And we also know our r of x. Okay, so what happens if we only divide by one of these factors? Well, if I just divide by x plus 1, really, this then becomes my q of x. And in essence, this is going to end up being a situation where I can use my remainder theorem, because the remainder theorem states that if I plug in my divisor, the root of my divisor, so p of negative 1, this will give me my remainder. And so if I plug in my negative 1 into this expression, okay, so if I do that, I'm going to end up with q of negative 1. Again, I have no idea what q of negative 1 is going to be. I can plug in negative 1 into this term here, so negative 1 minus 2. And the key here is when I plug negative 1 into this term here, that generates a 0. In fact, it generates a factor of 0, and anytime you multiply by 0, this whole expression now becomes 0. We don't need to consider this. And what we're left with then is we're left with the remainder term, which I can substitute negative 1 into. And this then, whatever this ends up being, is my r of x. Okay? In fact, not just r of x, but the remainder when x is negative 1. So working that all out, this becomes 0 plus that r of x works out to be, in this case, 3 times negative 1 minus 2 is going to be negative 5. So when I divide by x plus 1 using the remainder theorem, my remainder should be negative 5. So that's one way we can do this. So this is the correct answer here. Now there's an alternative way we can look at this problem, and we can look at it this way. If I divide a number and I have a remainder, I can divide by one of the factors and get the remainder of that, because what I do know, again, I'm going to write this out, so p of x is equal to my q of x times d of x plus my r of x. Okay. Now, if I divide by x plus 1, if I divide this expression by x plus 1, this is going to divide evenly into this part of the term, because those cancel out. So these divide evenly. And I then need to divide into 3x minus 2. Now this does not necessarily divide evenly into 3x minus 2. In fact, it doesn't. So when I divide into this term here, I should get a remainder. So when I actually do the division, x plus 1 into my 3x minus 2, okay, I'm going to end up with my 3. So I get 3x plus 3. I do my long division. Negative 2 minus 3 is negative 5. There's my remainder of negative 5, like I figured out in the previous problem. Okay, so there's two ways we can look at it. One way is using that division statement, and we can generate zeros in the division statement. Okay, which also means that if I divide by x minus 2, I can just plug 2 into this division statement and 2 into the remainder statement, get a remainder. Or the other way is I can divide by the x plus 1 factor, and I can see that these divide evenly, so the remainder is going to be generated by this division here, which I can just do as a linear division.